Welcome to this little lecture where I want to stress the difference between object-oriented programming and class-oriented programming. You will wonder what is it, and I will show you what is class-oriented programming and that you should not do it. So in the idea, this is really to think again what is object-oriented programming, and that sometimes you may think that you are programming in an object-oriented way, but you are doing it more in a class way, and this is not really nice. What you see is that sometimes you get class-based programming design where class are used as data holder, in the sense that instance of such a class would share the same data. So this means that all your instances will have the same values. So in that case, you said, okay, why do I need a class that normally generate instances, different instances, if now I generate instances, but they all the same data? And in this design, often what you will see is that you have to write a new class to represent a new instance. And this is really a big red sign. You should not. So in such design, what you see is that you have no real instance specific state. I did a sketch of that. So imagine the following hierarchy. You have a class changer that has different methods. It has the method command class, it has the method order, and multiform class. And for example, a subclass position changer will implement these three methods, and background will implement the three methods, and identifier will implement the three methods. And for example, position will just return the command class will return the command pattern as the command class associated, like command position. The multiform class will return form point, and for example, the order will return 2. And then we see that in all the classes the same. So background will return the command, that is the command background. The multiform will return the form color, and here the order 10. And the same for the identifier. What we see from this design is that, of course, I can have an instance here. Let's call it a identifier changer. I can have another one, no problem. I can have multiple of them. But they all share this, they all share that, and they all share that. So this means that each time I will send a message order, here, I will get 1. Here, order, I will get 1. So these classes can have multiple instances, but they all have the same state. These classes can have instances, and it will have all the same state. So, and now, if I want to create a new instance, basically what I am forced to do, I am forced to create a new subclass. So here we'll have a new subclass, here with a command class that will return something, an order that will return, I don't know, 42, why not? And there is something fishy. So let's analyze it a bit. So when I see such kind of class, I know that they are data-oriented. They are really static. They are static in the sense that I have to create a new classes for each new instance. And a class, in fact, represents only one instance. Even if I can create multiple of them, I cannot do much with them because I can only do the same, and they will reply in the exactly same state. So what we should see is that a class should describe instance shape, not values. And that's a key difference. Each instance can potentially have a different state. Maybe it is initialized by default to 1, but we can change it. In the design that I showed you previously, this is impossible. You can always get the same design. Let's compare now with the equivalent of the previous one with a simple single class. In that design, what I will do is that I will define instance variable, and some setters and getters. So here I have the getters. Each of these getters will return the value that are stored in this variable for each object. So here, for example, I will have a changer that is configured as the identifier that we saw on the previous slide. And here, this one will have the same information, but configured as the background and the position. And these three instances have different state, and they will behave differently. When I send the message order to this one, I will get a result that is different from that one, and I will get access to the state of this object. So with this design, we just create instances. They can represent multiple and different configuration of the same values, and potentially we could decorate them. So this means that we could say, oh, you are an instance, and I wrap you in another object, or I do something else with you. And to create one, we just specify what we want. Here, I said, oh, I would like to have a new one with, I don't know, something else than before, like, and here I will specify, okay, this is the new value. So with subclass, what we can also do is that we can potentially, if this is important for us, we can create a new subclass that's inherit from the previous one, where it has a specific initialize method where I define some default values, and I can have multiple instances here, but that would be a position too, because this is about position, but I could change. For example, I could say, oh, you know, I want to put a different command. So I could say command class, colon, or please use this one because I have an extension. So I would say command position 2. And then this means that this instance will have a different state from this one. But still, I encapsulate here some knowledge that apparently is better. So what you should see also is that from that perspective, this design need a discovery mechanism, or you have to store your instance variable somewhere. While in the previous one, you just ask the class. So you know, okay, there is one single entry point because this is the class. So if I write a changer position, there is one class changer position in the system. So it was providing a single access point. Now, if we use instances, it means that we can have multiple instances with different states. And in that case, we should explicitly register. So maybe we can have at the class level some annotation, or something that will have a dictionary to store them with ID or something like that. But this is much better in any way, in any case. So the conclusion is that when you need to define a new class to represent a new instance, this is fishy. Run away, change. A class describes the shape of its instances, not their values. Sometimes, for some values, you want to share them, and you know that they will not change. That's okay, but it cannot be general like that. So it means that there is something wrong. So in general, favor instance over classes, because classes are static, so you cannot create dynamically. So this means that if you need the compiler basically to really define an instance, there is something strange.